Greetings and welcome to BeIndie.biz. My name is Alan Thorn and I'm a game developer with lots and lots of experience who wants to share with you different techniques for making video games. Now this is part 5 of our Unity introduction course in which we're going to be creating an infinite runner game. Inside this game, the player must navigate a character throughout a level, avoiding dangers and enemies, and see how long they can survive. It's a pretty difficult game, so why don't you follow along with me and see how well you can do. Now in creating this game, we're going to be facing a lot of challenges. In this part, we're going to be tackling 2 challenges specifically. We're going to be improving the look of the lighting in the level, and to do that we're going to be looking at a feature called light probes. In addition to that, we're going to be using CineMachine to set up a camera to work inside this level to follow the player character. Now we saw in previous parts of this course how we could get a camera to follow the character just simply by using a parent-child relationship. In this movie we're going to see a different way to do that. In getting this far, we're going to get a system in place where we can have a camera follow the player character smoothly through the level in preparation for some more scripting that's going to come further along the line. So please do jump in with this course, continuing on from the previous. This is BeIndie.biz and join me in creating this infinite runner game. So in this section of the course, we're going to be focusing on 2 main things. Firstly, we're going to get the lighting right inside the scene. We've put our level together, but you can see already from the player character that the illumination is not behaving quite as we would want. For example, this character here, at least the rear side of the character, the back, the arms, the legs, it's really dark, unbelievably dark. And in a world where light is bouncing around the scene, there should at least be some illumination on his back, perhaps not quite as much, but it shouldn't be totally dark, which is exactly how it's looking right now, and we don't want that. So firstly, we need to get rid of that. We also want to make sure that the lighting in our scene is going to be behaving optimally so that everything behaves just as we expect it to. We're going to be working on that, and then the second thing we want to work on is configuring the character, the camera for the player character here, so that the camera is following the player character as he moves throughout the level and everything is behaving just as we want it to. I'm going to start by working on the lighting for the scene. Now we initially set this up a few videos ago to get the environment looking like this, but we're going to be improving that here. Firstly, I'm going to switch to the lighting tab here inside the Unity editor and take a look at some of the settings that we have. We're going to be tweaking some of these settings. Now initially for the skybox material and the sun source, we want to make sure that both of these are set to null. This is an indoor scene, so we don't need any sun or skybox material. Now for the environment lighting, I want to make sure that the source is not set to skybox, but is set to a bold color. This means that any ambient lighting bouncing around the scene, any base lighting in the scene is going to be based upon the color that we've specified in here, and this should be set to completely black to ensure that our scene, in the absence of any lights, has no illumination whatsoever. Now the next thing we want to work on is the real-time and the mixed lighting section. I want to make sure that both of these are enabled so that we're getting access to the real-time illumination inside Unity as well as any mixed illumination. The details of these we can look at in more courses, but right here we want to focus on setting up these parameters to get this scene looking good. So I'm going to make sure that we enable real-time lighting and mixed lighting here. I'm going to move down to the light mapping sections, and here there are some changes that I want to make that are incredibly important, and I'm going to be explaining what those are. First of all, I want to take a look at the light mapper settings. Now by default, this is set to the progressive CPU renderer. This is a new lighting system that Unity is using. I don't want to use this system, and the reason for that is because very soon we're going to be using a feature called light probes, and there is a bug that I found in Unity that prevents me from using the light probes correctly. So in this instance, and for this level, I don't want to be using the progressive CPU light mapper. I'm going to move to the light mapping field, click in the drop down, and I'm going to be choosing the older system Enlighten, which is currently marked as deprecated, but of course we can still access that feature. I'm going to be selecting the Enlighten system. Now this may force Unity to recalculate and rebake the lighting for the level. That's absolutely fine. You may see the progress bar on the bottom right hand side of the interface to indicate that the rebaking is taking effect. Now the next thing I want to check are the different settings that are being applied to the Enlighten light mapper here. Firstly, I want to make sure that for the light map resolution, which is the texels per unit, that I've specified a value of 4. Your default value may be much higher, but I'm going to specify the value of 4. You can always check that out by moving over here to the scene, for example. Let's take this view here, and in the shader drop down, you'll see there's a range of different settings we can choose from to tweak the drawing of the geometry here inside the viewport. I want to select Baked Light Map, and when I do that, you'll suddenly see a checker pattern applied throughout the entirety of the level across the floors, the walls, and the ceilings, this entire checker pattern here. Now as I change the settings inside the light map resolution field here inside the lighting tab, for example, if I bump that up to about 14, you'll see that as I do that, the size of the checker map here inside the viewport changes. Each and every one of these squares represents 1 pixel inside the light map texture. The light map texture is simply a texture file Unity is storing in the background, where it's saving all of the lighting information for the surfaces in our level. The higher this value, the better quality our lighting will be, but the more space it's going to take up in the computer's memory. So in other words, we want to keep this value as low as possible while keeping our scene looking good. And for a scene like this, I think a setting of 4 works pretty well. So I'm going to set that back to the value of 4. Now a bit later on, I'm going to be tweaking the fogging settings to kind of blur out the distance of the level a bit. And depending on our camera angle, this is going to make a subtle difference so that it's not easy for the player to see exactly where the level ends. The main function of the fog is simply to blur out the distance details. I'm going to switch back the baked light map settings back to the shaded view to bring back our fabulous level here. Now you can see that we've got our player set up so that he's standing here and he runs into the teleporter and he's going to keep looping back and forth. We saw how to do that in an earlier video. But even in tweaking these different lighting settings here, it still hasn't fixed the indirect illumination problem. When we look at the player character, you'll see that although the front of the character is completely illuminated, well, in fact, quite a large part is illuminated, but you'll see that even below the chest line, the character descends into complete darkness where we can't see any details at all, and that simply isn't believable. Even in this cartoon world of implied realism, where we're not even going for photorealism, even in this world, that is simply not believable. Now, for many cases, we can simply fix this problem by tweaking the detail settings of the lights, but that only works for static geometry. You remember from an earlier video that static geometry refers to the world, the environment here, all the stuff that simply doesn't move. Floors, walls, ceilings, that's going to remain in place throughout the entirety of gameplay, and for that stuff, we can really bake the illumination into the textures and get our environment looking pretty good. But we can't do that here with the player character because the player character moves during gameplay. So I can't simply select the player character and then mark that as static. Well, I can mark it as static, but if I do, the player character is not going to be able to move, so we won't do that. Instead, we're going to be using the light probe feature here of Unity. Now, the way I'm going to get this to work here is I'm going to select a single environment piece. In this case, I'm going to choose corridor section 3, which is actually the section of the corridor that the player is standing in. It doesn't really matter which section you choose. We're going to get it working for one of the sections, save the changes to the prefab, and it's going to propagate across all the other individual sections. I'm going to be choosing this section here. Now, with that selected, I'm going to right-click on the corridor section, move down to the light section here, and from the menu, I'm going to select Light Probe Group. Now, when I do that, you will see that it's created a new object here inside the level. and actually straight away in creating this light probe group, which you can see added to the hierarchy here, and you can see the light probes here inside the scene. But not only that, if you take a look at the player character inside the game tab, you will already see that the entire back of the character now is no longer completely black. In fact, if I move to the front of the character, you'll see that the illumination is pretty much fixed there as well. Now, what this is doing is these probes, these areas of the scene here, this probe, this probe, this probe, in creating these probes, it is saving information about the lighting in the scene, and as it travels through the scene, every single ray of light, these probes are saving information about light as it moves throughout the space. And it's using those values to blend the lighting across the character to make it look more believable. Now, the basic position of these light probes here is completely wrong. What I really want to do is I want to, for example, select our entire corridor section. You can see that it pretty much ends where that light probe has been positioned by default. I want to move the light probe basically to the center of this section, and I'm going to be positioning the probes throughout this section. So I'm going to grab the light probe group, and I'm going to start to position that maybe around about here at the center. Now I want to make sure that these individual probes, here is the center of the object, but branching off of the center, we have these yellow circle probes here. I want to make sure that all of the probes are contained inside the level. They don't penetrate through the floor, the walls, or the ceiling. They're actually contained inside the environment here. So I'm going to position the probes further up into the scene here. And now I'm going to begin to tweak their position just a little bit. If I select the corridor section again, you can see that the end is about here, the other end here. So I want to position the probes to kind of match up with those extremities. Now I'm going to just tweak the tab to get more real estate here to get a better view of this. So I'm going to move to the Edit Probes button. I'm going to make sure that the Edit Probes button here inside the inspector is toggled on. This will allow me not to adjust the position of the object itself, the object origin, but instead I can adjust the position of individual probes. I can select these by left clicking on them and begin to manipulate these as independent objects. So I'm going to grab these 4 objects here and then move them forward into the scene to about here. I'm going to do the same for the other 4 on this side of the level here. So these 4, bring these out pretty close to the edge, maybe about there. And then grab these and move them off to this side. Grab these and move these off to the other edge of the environment to about here. I might grab the top probes and move them closer to the ceiling to about there. Now that's pretty good. I've positioned the probes pretty much to the corners of the prefab, but I want to create some additional probes here to capture the diversity of light as it moves within this interior space here. I can do that by selecting, for example, these 2 probes, and I can select multiple probes simply by holding down the Shift key on the keyboard and left-clicking the individual probes. With these 2 probes selected, I'm going to move to the inspector and click on the button that says Duplicate Selected. This will allow me to create an additional set of probes here at the center. That's looking pretty good. I'm going to choose Duplicate Selected again to move these roughly in line with these ones. Grab these end probes and Duplicate Selected again to bring these in once, and Duplicate Selected one more to move these into here. So we have a reasonable grid of probes that's capturing the light in this complete interior space. So that's looking pretty good. I'm going to exit the Edit Light Probe Group mode here, grab my corridor section, move to the prefabs, and drag and drop the corridor section into the prefab to update those changes. When I do that now, and I move, for example, to this corridor section, and I expand that, you can see this too has a light probe group, and now we in fact have a complete light probe group that has been propagated throughout the scene, and I'm pretty happy with how that's looking. I just want to check my light probe group here. Yeah, that's looking pretty good. So now I can select, for example, the player character, and as I move the player character throughout the scene, the illumination across the object is going to change, and even when I move him into a darker area like this, you can see the back. We can still see quite a lot of the details of that back, but it's also taking into account the fact that this area of the level is darker. So that's looking pretty good. Now, if you don't see the changes of this lighting taking effect on your player character, then it is probably because you don't have light probes enabled for this mesh object. You can easily do that, and I'll show you how. You'll move to the hierarchy panel to select the player object and expand the group here, and we're going to select the different mesh pieces that make up this player character. When you select on the cyborg base object here, it doesn't actually contain a mesh renderer on this object. We simply have a rigid body, a capsule collider, and an animator object. There's no mesh here. That's because it's on these three basic pieces down here. In fact, the body and the mechanical section, which represents the mechanical parts of this object. Both of these objects feature a skinned mesh renderer, and this is where we can decide whether this object's being affected by light probes. If you select the skin mesh renderer and you move down to the probe section, and for light probes, you want to make sure that this value is set to blend probes. That will take into account the light probe groups here inside the scene. Perfect. That's looking pretty good. We now have the player character being affected by light probes inside the scene. I can switch to the game tab to see the effect that has now taken, and that is looking much, much better. Now we also want to make sure that the complete environment objects here inside the scene have light map UVs enabled, so that when that light mapping is baked into the light mapping texture here, these objects are going to look correct. Now it just so happens that in the case of this project here, we do have light map UVs generated for the environment object. Let me show you how to generate them for these environment pieces if you don't have it already enabled. You want to move down here to the project panel and move to the barking dog folder. You'll remember this is based on the asset package that we imported from the Unity asset store that contains all of our mesh assets. Now I'm going to go to the 3D free modular kit, move to the meshes so that I can see in fact the entirety of the meshes that we've imported. And I want to, for example, select every single one of the meshes that we've imported here. And or in fact, I just want to deselect the materials folder. Now I want to move to the models tab for all of the meshes that we've imported and move right down to the bottom and ensure that the option generate light map UVs is enabled for all of these objects, and then choose the apply button to apply those changes to all the meshes that we have imported. That will ensure that the meshes are optimized for light mapping. Now Unity does offer additional settings to tweak the values of these light mapping settings. You can click on the expandable arrow here to tweak some of these values, but I'm going to go ahead and leave them all at their defaults because for this level, that's working pretty good. So I've now added to the level a complete lighting setup that consists of baked illumination, the baked parameters set here on the lighting tab. We've enabled the enlighten, the deprecated enlighten system, and I've also gone ahead and added the light probe objects to each of the corridor sections. This is absolutely fine. If you're watching this video much later in a much later version of Unity, at which point they may have discontinued the enlighten system, then you can switch to the progressive CPU or the progressive GPU system, and at that time the problems that were applying to the light probes may no longer apply and they may work just fine for you. So in doing this, we've managed to configure the complete lighting setup The next thing that I want to do is to go ahead and import a camera system into the level, a camera that is going to continually follow the player as he moves through the level. You can see from the game tab here that when I press play on the toolbar, we have the character that simply runs into the distance here, and that's looking fine. We have the camera also following closely behind the player character, and that's pretty good too. Now the reason this is happening is because we've simply taken the main character and we've parented that, or we've made that a child of the player object, so it's following the character. Now you can simply leave it just like that, but you can also use the CineMachine tools here inside Unity to create a more sophisticated setup. We don't have to do it for this project, but I'm going to import them and show you how to use it anyway, and that's what we're going to be doing next. So we've seen how to configure the basic lighting for this level. The next thing I want to do is to tweak the camera following the player character. Now we've simply added this camera as a child object. I'm going to remove that to place it back into the scene hierarchy and make sure that it's not going to automatically be following the player character. Let's test that by pressing play on the toolbar, and this time the camera should remain in place as the player runs into the distance. That's pretty good. Now the next thing I want to do is to import the CineMachine asset pack. This is a package of assets that accompanies the Unity engine that allows you to intelligently control cameras. It's pretty easy to use, it's pretty easy to set up, but my goodness me, it's really powerful. Let's see how that works. Now to access the CineMachine package, I'm going to move to the menu, choose Window, and then choose Package Manager from the menu to select that option. This will display the Package Manager. Now by default, it's going to display a list of the packages that we have installed, and then it's going to rebuild the entire list and suddenly display a list of all the packages that are available. We can just view the ones that we already have installed by clicking on the drop down and simply choosing In Project. Now, although it shows us these packages as being installed, we didn't manually install them. They came pre-installed with the project when we created it. I'm going to move back to the All Packages section and move to the section that says CineMachine here, move down to the bottom right-hand side, and then choose Install to install that package directly into our project. Now you may need to wait a while it compiles all of the assets that you need. These are not really going to change the configuration of the project panel pretty much down here. These assets are going to be installed in the background so that we can easily uninstall packages if we need to without having to worry about any changes it might have made to the project panel. Now, when CineMachine has been installed, you can always tell that it's been successful. There are two ways that you can do this. The first way is by selecting the CineMachine package here in the Package Manager. You'll see on the bottom right hand side, the Install button will have changed to Remove. I'm going to close the window, and you will also notice here from the file menu at the top that a new option, CineMachine, has been added. And that's exactly what I want to use right here. I'm going to click on CineMachine, and then I'm going to select Create Virtual Camera. Now, when I create a virtual camera inside the scene here, you can see that we have several different things displaying. We have this virtual camera, and what that's going to be doing is it's going to be linking to the main camera that we have here inside the scene, so that actually this object doesn't contain any camera information. It is instead going to be controlling the main camera that we have specified here. In fact, in selecting this main camera here, you'll see that a component has been added to it called the CineMachine Brain, and this brain component, it links our camera, which is actually going to be rendering the scene, with data provided by the virtual camera here. Now I want to configure this virtual camera to effectively be taking a look and watching the player character. Now this requires us to tweak some of the settings here inside this CineMachine virtual camera. The first thing that I want to do is I want to specify which object this camera is going to be looking at constantly. And well, we know what that is. That's going to be the player character, right? So I'm going to drag and drop the player character, the player root specifically, into the follow field. You can see that in that happening immediately, we have the CineMachine virtual camera here change what it's looking at. These changes are being updated here, notice, inside the game tab, not the scene tab. So I'm going to be viewing things from the game tab here. I'm going to drag and drop the player root also into the look at field so that two things are happening. One, the CineMachine virtual camera is going to be continually following the player, as a third-person camera would be expected to do. And second, it's going to be continually looking at the player character inside the viewport. So I've set that up. I want to make sure that the standby update mode is specified here as round robin. And I'm going to move down slightly further to the section here for the body with the transposer field. Here I want to specify what the character is going to be locked to. Notice I can also click and drag on this setting here inside the view, and notice that as I move this around here and I'm choosing what the camera is looking at, you can see the settings changing directly here inside the inspector. I'm going to press Ctrl-Z to undo those, to reset those back to their default. Now inside this Y field, you can see that this controls the elevation of the camera inside the scene. I'm going to set that to maybe a value of 2.70 here. Now the Z field is going to control what we are zoomed in on, and I might try a value of -4 and begin to raise and change some of these values, maybe to 1.2, something kind of like that here. And then I might move over to this Z field, tweak that just a little bit to maybe something kind of like this here. Might choose the lens, make sure that my field of view 40 is exactly right. So that's 40, that's looking pretty good. I might tweak some of these settings just a little bit further here, maybe 0.4. No, I'm going to leave that, in fact, dead at the center. So that's looking okay. I'm going to tweak just these just a little bit. I want to come down a bit further so that although I see the head of the character, I'm going to tweak that just a little bit to come back out of here to follow the character. Maybe tweak that just a little bit. Tweak this some more. Maybe something kind of like this. We need to get a good view of the distance so that we can still see objects approaching in the level without seeing too much of the distance here. So I'm going to grab and zoom that in. I think that view here is probably pretty good. I'm going to press play and see how that takes effect here inside the viewport. Okay. Yeah, we can still see perhaps too far ahead, and I'm not too pleased about that. So I might tweak some of these settings a bit further here, maybe to -3, and I'll press play on the toolbar to see what we get here. Something kind of like this. Going to leave that setting pretty much in place at the moment. I might change that just a little bit to -4. I'm going to change the X, Y, and Z damping settings, which control the smoothness of the following for the camera, as well as the horizontal and vertical damping. Change those to 0. I might change the look ahead smoothing to something a little bit less to, again, change how this character follows the player. Press play on the toolbar to tweak that just a little bit further. Let's see how that's looking. Yeah, that's looking pretty good. I might tweak this down while the game is running just a little bit. So maybe something, yeah, I think that's looking pretty good. So I'm going to change that to 0.04. See how that looks. Maybe change that down a bit further. So that's 0.44, beg your pardon. So 0.44. Press play again on the toolbar, still being able to see things in the distance. I may even try to bring my Z down a little bit further to negative 4.22. Again, just trying to maximize the amount of the level that I can see in the distance here. Yeah, and I think that's looking pretty good. Move back to the camera to see that. And there we can see we've got the camera following the player. And this is no longer a simple case of parent-child. I'm using CineMachine and the CineMachine brain to continually chase this camera in a smart fashion, so that's always looking ahead as to what we are chasing. I can maybe change the default blend a little bit here to again tweak the blending of this camera as it moves through the player, as the player moves through the level, I beg your pardon, but I'm pretty much happy with these settings as they are. Now there still needs to be some tweaking going on, and the main area of tweaking here is in fact the loop point. And the reason we're getting this really sudden change happening here is simply because although we are moving the player character through the level, the player will then hit the teleportation point and jump back to the beginning of the level, but we don't also move the camera with the player character, so that as the player moves back to the beginning, the camera is still left over here, and then it needs to jump to follow the player character back to the beginning of the level. And well, that's not really a big problem, but it's having a big effect here inside the viewport. It's really affecting the transition between the player jumping from this point here to this point here. It's spoiling the entire effect of the loop. So in the next movie, what we're going to be doing is we're going to be revisiting our teleportation script here inside this teleportation camera to really start to change up how this camera is working, how the teleportation is working, so that we can get a completely seamless blend between the player jumping from point back to the restart position. It's not rocket science. We're going to see that it's actually pretty easy to do, but this is something that's going to require us to now tweak our script file for the teleportation script. So stay tuned. In the next movie, we're going to see how to do that. I've been Alan Thorn, and you've been watching BeIndie.biz. Please do subscribe to our channels for the best tutorials in game development across Unity, Godot, GIMP, Blender, and pretty much any other kind of free software you can imagine.